part 2 of the practice exam. I'm going back to question 6 because more embarrassing than the fact that I thought there should be a diagram is the fact that it didn't need to be a diagram. When it said illustrated by the tracks, I assumed it was talking about the next question, which says, well, never mind. Anyway, who cares? Question 6 is based on this information up here. And we already said that in a bubble chamber or cloud chamber, if you have a straight track, there's no charge. If you have a slightly curved track, then the particle is charged. And if it's highly curved track, then it's also charged. What's the difference between the slightly and the highly curved one? Well, if it's only curved slightly, then there's a good chance it has a very high mass or a greater mass. And if it curves greatly, like that, then it has less mass. If it only curves like that, then it has it's a bigger mass. So question 6 says, from this list up here, assuming the same speed, the paths of the lighter and the heavier charged particles are illustrated by, so if they're both charged, then they both have to be curving, and one's going to be slightly curved and one's going to be highly curved. Now the lighter is going to be highly curved, and the heavier one is going to be slightly curved. So the only acceptable answer is C, 2 and 3. Okay, back to where we left off, which was question 15. According to the standard model, a beta negative decay indicates a transformation of quarks in which, so beta negative is where a neutron turns into a proton, right? A proton with a positron, a beta particle or an electron and an antineutrino, and a neutron is a 2 downs and an up, and a proton is 2 ups and a down. So what happened? One of the downs changed to an up. Easy peasy. A down changed to an up. C. 16. What subatomic particles make up the atom? Gold, AU gold, 79, 197 gold, or sorry, I should say gold, 197. So this is for your A value and your Z values. That's the atomic number. That's the number of protons. That is the number of nucleons, and therefore to get the number of neutrons, you're just going to go 197 minus 79, and you're going to get the answer A. 79 protons, 197 nucleons, 118 neutrons, and assuming it has no charge, 79 electrons. In order of increasing magnitude, what is the order of the following forces of nature? This occurs on diploma tests every now and then. It's a straightforward knowledge question. You just have to know the strong nuclear force is the strongest, though gravity is the weakest. The only question is, where is the weak nuclear force and electromagnetism fit in? And surprisingly, you may find this surprising, electromagnetism is stronger than the weak nuclear force. So the answer is A. 18, another knowledge question. Binding energy refers to the energy required to trap all the nucleons in the nucleus, the energy required to liberate all the nucleons from the nucleus, the energy required to liberate them from the ground state, the energy required to cause radioactive decay. No. So it's got to be A or B. Is the energy required to trap all the nucleons in the nucleus, or the energy required to liberate them? Well, if you recall, nucleons or neutrons, when they're just all separate, that's some neutrons, some protons. When they're all separate, they have a greater mass than when they are combined. Okay. So the binding energy is A. It's the energy that it requires to keep them or to get them all together, because you have to use some of their mass converted into energy, and that's the strong nuclear force. What is the daughter product of 247 CM when it undergoes alpha decay? Alpha decay. 247 CM. I don't even know what CM is. Undergoes alpha decay. You just got to balance it. What goes here? It must be 94. So 2 and 94 makes 96. This is a 4. What must go here? 243. It must be D. Which of the following decay processes are possible? This is similar to the previous question. It's just balancing. Which ones of these are balanced? And as you can see, the first one is just the question we just did. Because remember, an alpha particle is a helium nucleus. They've just rendered as heat as an HE. So this one is balanced. How about the next one? 222. Yes, the top is balanced. Is the bottom balanced? No, because you have 86 over here and you have 90 over here. So no, that is not balanced. Is number 3 balanced? 131, 31. 53, -1, and 54 is -53. So yes, that one is balanced. And what about the one on the bottom? Is that one balanced? No, it is not balanced because the top is not. 2, 2, 2, 1, and 2, 2, 2. Answer is 1 and 3. Balanced. Number 21, nuclear, another knowledge question. Nuclear radiation can cause many potential health hazards to biological organisms, such as radiation sickness and genetic mutation. Much of the danger is the ability of alpha, beta, and gamma radiation to penetrate the body and do the damage. So you just have to know that alpha penetrates the least, beta penetrates the second least or the second most, and gamma penetrates the most. The relative penetration ability of alpha, beta, and gamma. So it's going to be alpha is the lowest and gamma is the highest, and beta is the in-between one. So that's going to be C. Okay, we've got a Rutherford experiment. You got a radioactive source, and then you have some particles being emitted from this radioactive source, and you've got a magnetic field that is going into the page, and these particles coming from the radioactive source, one of them is going straight, one of them is curving off to the left, one of them is curving off to the right. Which is 2? Well, that's the easy one, because if it's just going straight, then it must have no charge. Which one of these has no charge? Alpha, beta, gamma, or a proton? Gamma. But let's say I asked you which one's beta. Which one would that be? So what you would have to do, if it asks you which is the beta particle, you would have to say, and when it says beta, unless it says beta positive, you always assume it's beta negative. So that's going to be beta negative. So a beta negative, you have to use your left hand. Your thumb is going to point up, your fingers are going to point into the board. Which way is your palm facing? It's facing to the right. So this would be the beta. All right, now the question is, what about number 1? What's number 1? Is that an alpha or is that a proton? And really, there's not enough information. You can tell it's going, you use your right hand rule, so it's both alpha and protons are positive. Since both alpha and a proton have a considerably more massive than a beta particle or an electron, then they can have a much less curvature or a much bigger radius. And in this specific one, it's not really drawn to scale enough. For example, if this really was a beta particle and this really was a proton, then This would be more like this, and then this would be, it'd be huge, it'd be huge. This would be a really, really small. Yeah, there's not enough information for you to be able to tell if this is an alpha or a proton. It could be both. Okay. Ooh, 23. If deuterium transmutates to beta negative decay, what is the nucleus produced? Deuterium is hydrogen 2, goes through beta negative decay. Beta negative decay, and then it's just a question of balancing. If I have a 1 here and a negative 1 here, what must I have here? That's right, a 2. And what if I have a 2 here, a 0 here, I must have a 2 here. So what is this? Well, if there's 2, if the atomic number is 2, it's automatically helium. C. Interesting helium though, isn't it? It's a helium with only 2 protons and no neutrons. 24 you can omit. Right. Easiest question on the test. We don't talk about activity, and so we're not doing it. Radioactive isotope has a half-life of 4.5 days. What fraction of the original sample exists 9 and 18 days respectively? So once again, you can do this with logarithms, and you can do it really the complicated way, but it's much easier just to guess and check the answers. So you're going to, if it has a radioactive half-life of, if at time 0 amount, I'm going to put a 1 because it's the full amount. Right? At 4.5 days, it's going to have half the amount. At 9 days, add another 4.5 days, it's going to have a quarter of the amount. Now you got to be careful here. Don't just start doubling this number, because it's every 4.5 days. So this next one is 13.5. It's going to be a quarter, and then it goes to 18. Sorry, not a quarter. Did I say a quarter? I meant an 8. And then it goes to 1/16. So the correct answer at 9 days, it's a quarter, and at 18, it's a 16th. So not a difficult question, but one that you could get tripped up on quite easily. 26, we're going to do this one. We'll do this one mathematically. So once again, you could just guess and check the answer. But let's just do this one using the math skills we have, especially since all of you guys have already done Math 30-1, so you know logarithms. So the half-life of a theoretical isotope is T is 7.2 hours. There are that many atoms initially. How many atoms will remain? So the initial amount is this number. We're trying to find out the final amount. So we don't actually need to use logarithms. This is just a really straightforward half-life question. The time, the half-life time, remember we did a T over D, so the half-life time is 7.2, and the actual time is 60. That's pretty straightforward. Plug in the numbers, and you're going to end up getting 1.4 times 10 to the 20. Answer is A. Okay, can we get 1 or 2 more in? Let's try and get this one in here. What's this one here? Fluorine 20. So we got a graph fluorine 20. It says based on the graph above, the time required for 17 grams of fluorine 20 to decay to 4.25. So what are we going to do there? Well, we're going to say if you have 17 grams of fluorine 20 and it's decayed to 4.25, because this is the amount of fluorine as a percentage, right? Starts at 100% and then goes to 0. and then we got the time on the x-axis. Because it's represented as a percentage, we want to ask ourselves, what percent is 4.25 of 17? And you can probably look at that for a couple of seconds and figure out it's a quarter, isn't it? 4.25 is a quarter of 17, so it's 25%. 25%. 4.25 is 25% of 17. So then we're just going to go to 25% here. There it is. The answer is 30 seconds. Okay, that ends video number 2.